handling errors in the recent 10 years has become a much more complex topic because before that we had the monolith, and in the monolith most of our code was running inside the same process. Now a single monolith can be distributed into tens if not hundreds of services. This serves both good purposes, but we should now employ new procedures in order to know how to monitor all this distributed system, and handling errors and failures, as we have just said, has become much more complex. So in distributed systems, we can have multiple kinds of error. For example, we could have a transient failure where we call a system and due to some transient problem, the system could not reply to us. For example, of a transient problem is that the system that we have called was busy, okay, or that we needed to establish a connection and we didn't have enough time to establish connection. So once we establish it, then our call could succeed. This is an example of a transient problem. Another example of a transient problem is latency. The system that we call would reply to us, but in different times of the days, the latency of the target system would be different. So you could call a system, it would be 10 milliseconds, and then at another hour, more busy hour of the day, it could be 100 milliseconds. And in your side, it could be the case that you handle different these cases. So this is another example of how transient the system has become. Monoliths are excellent when you have a new project, and I would say that you should stick with monolith as much as possible, but this is a different topic that we should discuss in another episode, because you could stick with the monolith and you could also distribute it. And the way to do this could be by having a single source repository that you all compile into a single monolith. Okay, of course this has drawbacks, but once you hit the drawbacks, then I claim it could be very simple to split it, because if you designed it well, then you design this monolith as if it's a distributed system. Okay, you could keep different parts of the database, different modules. You could keep very good separation inside the monolith so that when you do need to go into a microservice, it would be very easy. Of course, if you're a company of hundreds of people, then maybe a monolith wouldn't be such a great idea, although you could do that. Okay, I would do that with a clear separation of modules and clear separation of databases, because I think the complexity still does not justifies. But of course, every case should be handled separately, so there could be cases where it would be a better practice and other cases where not. However, what I wanted to say is only that even if the cases where you decide that a monolith is the way to go, you should decide it as if it's a microservice. You should have clear separation inside and separate the modules and such forth. So when you call another service, you need to take care of all the errors that could happen. And one of the ways to take care of errors is with the retry. Okay, so we are just opened a Pandora box with the retry, because the retry is like you saying, I am very important. If I failed, I am going to assume, as if I'm assuming that you are less important, because I'm doing a retry to you. I mean, I wanted this request. I'm just going to call you another time, okay? I don't care that I'm wasting your resources, because now instead of a single request, I'm making another request. I just stated that I'm much more important, that I less care about your load. I more care about the response. I want a response. Therefore, I'm doing a retry. If you keep this in mind, and you would remember that when you do a retry, you claim that you are important, you want the response, okay, and you can overload the other system, okay, intentionally or not intentionally, and you are also not the only one making a retry. Therefore, you are overloading the next system. But of course, a retry have a very good place. We should employ it, of course, but we should also remember the limitations. So a good use case for a retry could be to do this when you know that the error is transient, because if the error is not transient, or you're not aware of the source of the error, because if I'm the client and I made a request and the error was a bug in my client code, I'm taking it to extreme on purpose, then of course I should not do a retry. It would not help. Okay, the bug was with me, with the client. What would help if I will do just another retry? So I should examine the error that has just happened and decide whether to call the other system again or not, because failure would happen, okay? And when a failure happens, you need to decide what to do. There are so many moving components inside the distributed system. You have the VIP, you have the other servers, you have the network, you have the load balancers, you have the software, you have so many moving components, you have the disk, you have the CPU, other services, that it's almost impossible to make a system that will not recover and will not have failures. And there are specific programming languages even designed for that, like the Erlang programming language. So did you make a phone call and notice that it's very reliable, more reliable than the other systems? Because it was designed with the thought of failure in advance in a programming language which was designed for this purpose, okay? So when you call another system, we said you should think about the errors, and then when you think you need to retry, then you should take care of how many times do I retry, what do I do if the retry fails, do I have timeouts? If I'm calling another system and the system does not answer me, should I employ a timeout? And I should remember that if I'm doing the retry, if I'm having the timeout, other systems will do the very same thing. And once multiple systems are doing this retry, we're going to consume resources from this next server. We should take this into account. So we should employ retry when we think we have a good use case. We said, if the error was in our client, to take it to the extreme, there will be no use for a retry, okay? Because the bug was on our side. What would it help that we would do a retry to the server? If we know that the error was transient, and we know with good chances that once we call this server, there is a very good chance that we would receive a good response, then yes, we should retry, because if not, then maybe the client, the mobile phone, whatever it was, would be another request to us, and this would eventually overload the system. This takes into consideration that the call was from a single client and not like a background process, but we could also talk about background processes. So we said we had a call to the server, we failed, we're doing a retry. So in order not to overload the subsequent server, what we should employ is a backoff. What does a backoff mean? It means we play some time between subsequent retries. So don't just do like a for loop of the retries, put some time in between the retries. Maybe the first retry could be immediately, maybe even the third would be immediately, but once you need to do more and more retries, you need to have a backoff. When you do a retry, you should make sure that the service that you call does not have a side effects. Because if you call a service and that service would have a side effect, then you would call the retry, you would do another request, and who knows, maybe you just booked another room or booked another car, okay? So you should make sure that calling and making these retries are what is called idempotent, meaning that you can safely retry them and there won't be a bad side effect out of it. Once you do the retry, you need to remember that what was the use case? What was the scenario that you did a retry? Because if the scenario originated from a real human user that used a mobile phone, the request has failed, now you do a retry and the retry fails. This sounds fine. Okay, this is like a little bit of random. But if you have a background process that wakes up every night at 12 in the midnight and is scheduled and is starting to run, and now you do retries, then you might have now bursts because maybe many backend services are waking up at the same time at the midnight and doing some background work. So you should take this into account. Think whether your scenario is a scenario that is scheduled or a scenario from a client. If it's from a client, it's a little bit more safer to do the retries, because if it's from a scheduled process, then you need to make sure that your retry is not causing bursts. If you are from doing this from a background process, which is scheduled, then you can employ the jitter. The jitter means that you are inserting some random amount of time before making the next retry. You do this with exponential retry, exponential time before the retry. And once we employ this randomness into the retries, then we would reduce the chance of having a burst and a spike on the target service. But now that we have added more complexity, it's all a matter of trade-off. You are adding a feature, you're moving from a monolith to microservices. It's a trade-off. You benefit some things, you lose some things. We added retries, we benefited some things, and we lose some things. Now that we add this randomness into the calls, we benefited. We got some things. What did we get? We get better chance of not having a burst and spikes into the service. But what did we lose? We lost predictability. And if you listen to my previous episode, you know already what I think about predictability. It's one of the core and the basis. It's like the skeleton that should be in front of you whenever you design a distributed system. Predictability. So when we do introduce a random, we want to make sure that it's like a semi-random. Okay, for example, that later on when we example why did this problem happen, we will see a pattern, we will know what happened, and we will not see just a whole mess of randomness. Okay, for example, this could be that the jitter and the randomness is dependent on the calling system. Okay, if I have a jitter or randomness of, let's say, 60 seconds, then maybe I want to boost with a certain amount of retries for a certain amount of time, dependent on the calling service, and then I could see some patterns. And of course, you should be able to see who was the client that caused these retries. This would help you in troubleshooting. So you should employ retries, and you should also employ timeouts, even when you do some local calls into other processes that are on the same host. Timeouts will enable you to like break a call into another service. So this would mean that I, as a client, I call a service. The service is overloaded. I want to do a retry, but I can't do a retry unless I have timed out. Okay, there could be multiple cases. I am calling a critical service. By critical means, I need the service response in order to return a response to a customer. For example, the customer wants to book a vacation. I didn't get the name of the hotel. I cannot proceed. Okay, I just cannot. I could introduce some other search results. Okay, if it's okay to return some other results, it's okay. But if the customer is like booking this hotel and I need to show him the name, I need to show him the price, that it's practically impossible to return this. So I need this response. I need to know what is the price. Okay. And in other cases where it's not that critical to show the response. For example, I got only 10 images of the hotel out of 12. Okay, it's not that super critical in a search result. Okay, I could go in the background and bring them, and I do not need to block anything. So when you design your retries, we have said you need to take care of a few aspects. You need to take care of whether you should do a retry. If you think that the response would give you better results, then maybe you should do a retry. If there is no chance that the retry would succeed, don't do a retry. And when you do a timeout to a service, this goes along with the retries. When you do a timeout, consider trying to have it try to have a low timeout, because if you can have a low timeout and it would serve your needs, it's better than a longer timeout. But again, it's really depends on the service and what you call and how critical is the target. But you need to take care. In general, it can range from a very low timeout to a very big. It really depends on the use case. So when we do the retry and the timeouts, we said that we introduce some randomness. We said that we introduce some exponentiation, meaning each retry comes at a longer time. This is one lane. And also what you could do is because if you have multiple layers of services that each call each other, then this can be an exponential explosion, because service A does a retry to service B, B does a retry to C and D, C does a retry to E and F, and it explodes. It's like a tree, okay? In order to avoid this explosion, what you can do is to cap this amount of retries, like you say, okay, I'm going to have for this request ID, 100 total retries that I can do, and each retry consumes one retry. In this way, you now have a retry, you have exponential, you have randomness, you have predictable randomness, and now we also cap it. Okay, you see how much complexity we are adding. This is okay. If your system is microservice, it's okay to add all this complexity. And then what we should do also is, if we got too many retries and the system start to mess with all these retries and stuff, you should break it. And we have just broke it with the capping. Okay, the capping is what allows us to utilize like the design pattern that is called a circuit breaker. Okay, we are breaking. We are saying, okay, I'm not allowing for more than 100 retries. And as we said, when you do a retry, so you should remember that each retry that you do means that the subsequent service will do a retry, okay? It didn't plan to do a retry, but it's going to do another retry. And if there was a side effect, it would be caused by this other service. So you should be careful. You should think when to do retries and not. We should be aware of it. Employing retries is better than not, but employing retries should be done when you know that the error is transient and that you can fix it. And then when you do employ the retry, try to have some mechanism. And as we saw that this mechanism is so complex, then when you design a server and you provide a client library, try to have already this retry mechanism in the client library so that you can share the code of the retries. You can also make a shared library for retries. And also, once you share the code for the retry, it would going to be very easy for the client. It would just say, client, I'm calling the server. I want this amount of retries with this randomness and such stuff. And of course, only for transient errors. Never do retries for error that you know that will never fix the problem if you do a retry. So we have introduced some complexity into the system, but it would assist the reliability and the availability of the system only if you take into account that you should cap the retries, you should avoid bombing subsequent servers, you should know the ripple effect that the retries are causing, and you do a retry when it's needed, when in the distributed system you're trying to call something and there was a transient error, you do a retry, but you don't do a retry when it's not helping you and it would even decrease the availability. So retries and timeouts are a very powerful mechanism in distributed systems. And when you try them, what you should make sure is that the problem was indeed transient. And also, when you do employ the retry, see what would happen if you take the same amount of time in order to avoid the retry in advance. Because if you just make a retry, it's like saying again, I'm more important, I don't care, I just call the next service, but maybe there was a problem that caused all this error, all this transient error. So try to get to the root cause of the error and try to fix it. If some service is not fast enough, if some service needs more resources, or if it needs tunings and performance efficiency increase, maybe you should take the same amount of time that you invested in the retry and try to fix the problem from the root cause. Only if you know or that you cannot fix the root cause, it's not possible, then you employ the retry. Retries are very powerful. They are used all over the internet and all over projects and all over microservices and also internally inside services. These are very powerful concepts, but use with care, okay? Use with care, try to fix the root cause of the problems, try to avoid retries because they are complex. And if you could not avoid them, do the retries, introduce some randomness, some exponentiation, some capping, and you are good to go. So I hope you enjoyed it. I think it was pretty interesting. I will see you next time.